esteemed expert Ms. Shipra Divakar, who holds an MTech in electronics and is currently working as AGM in the utility department at HealthCaps India Ltd. With over 5 years of industry experience, she brings valuable practical insights from the industrial sector. She hails from Nawashahar and has rich exposure to utility management and electronics applications in industry. We are honored to have her with us today. Welcome, ma'am. Hello, ma'am. Please unmute yourself.
Hello, everyone. I hope I'm audible to all of you.
Yes, ma'am.
Oh, thank you so much, ma'am, first of all, for making me as a guest faculty here and for the wonderful introduction. So let's hope for learning a new experience and new things from this seminar. So let's start with the introduction about the topic we are going to use today. So let us discuss the use of biodiesel as an alternative fuels. So before starting its use, we all should know about what is biodiesel, why it is necessary, and what kind of benefits we have to use this. So let's start with the introduction. So hello everyone. I'm very happy to be here with you today. My name is Shipra Divakar and I'm working as AGM Utility Department at HealthCaps India for last 5 years. So today I will speak not only as a teacher but as working as this industry professional. Before I start, let me ask few questions or let me make you think how many of us are using diesel engine. If we think about it, many of us are using diesel engine vehicles or in industries. Many of us are using, or we can say maximum of our engines are using biodiesels, right? So this question or this thought is already explained the need of diesel engine or to improve the diesel engine or the main topics, the use of biodiesel engine, right? So as we all know that today's world depends heavily on diesel engines, especially for transport, agriculture, generator, ships, and heavy vehicles. However, fossil fuels are limited, polluting, and mostly imported, which creates economic and environmental problem. It is not easy to import such amount of diesel or fuels from other countries. As we all know, global energy demands is increasing every year due to population growth and industrialization. Many countries depends on on imported petroleum, making them vulnerable to price and drives the supply distribution. Even though electric vehicles are growing, heavy duty and off road sectors cannot fully depend on the electricity yet. If we think that all the diesel engine will replaced by electric engines, which is not possible today. So, which is the easier path to improve the engines? We can't say that we should replace all the engine with electric engine. Rather, we can make a clean fuel which can help us to improve the quality of fuel and also reduce the all the disadvantages of diesel. So here few important points we can discuss here, that biodiesel are helping to improving energy security. It will reduce air pollution, supporting farmers and rural economic, converting waste into useful fuel. Thus, biodiesel acts as bridge fuel between fossil fuels and sustainable future. So we should make a bridge. Till then, we do not have the sustainable future. So let us discuss the fundamentals. So today's the camera here. So today's agendas for the seminars, we have motivational and fundamentals. We will discuss the diesel versus biodiesel. We will discuss the feedstock and production process also, fuel properties and standards. We will discuss blend, that is B5 and B100, also its handling, engine performance effects, combustion and emission, practical considerations, LCA, economics and policy, case studies and summary. So here we have a graph which is clearly showing the energy demands. Rising the energy demands, we all know global transport energy consumption is projected to grow the significantly by 2050, driven by emerging economics and freight and transports. Import dependence, we all know that reliance on imported fossil fuels creates vulnerability to geopolitical price volatility and supply chain disruption. Heavy duty necessity, yes, while light duty electrifies, heavy duty off road sector requires high density liquid fuels like biodiesel as drop in solution. So, resources depletions and so here we are discussing that we have few flaw points with the diesel, that finite fossil reserves, conventional petroleum reserves are finite and geographically concentrated, created long-term supply instability risk. So as the demand is increasing, as the requirement is increasing, so we have a risk that the long-term supply will not be available for this fuel. Feedstock diversification, ability to utilize diverse biomass sources like waste oil, animal fat, and non edible crops like jatropha and camellia, rural development and value chains, localized production supports agriculture economies, creates jobs, and reduce the dependence of foreign energy imports. So we have few points regarding air quality and climate. Here we have graph that clearly shows that biodiesel is producing less pollution as compared to petroleum diesel. So let us discuss with petroleum diesels. Petroleum diesel, a fossil fuel, fossil derived mixture of hydrocarbons, primarily paraffin, cycloalkanes, and aromatics, contains no oxygen. Biodiesel fatty acid methyl ester produced via transesterification, an oxygenated fuel strictly defined by standard ASTM D6751 or EN 14214. So here one thing we have to discuss, the process of transesterification, where fats or fatty acid methyls, which is produced with the react when alcohol is reacted with the edible or non-edible fuels. We have some condition that we will discuss later. Also, biodiesel have oxygen, which is very useful as it is a oxygenated fuel, which is very useful to combust carbon monoxide completely, also convert into carbon dioxides, right? Which reduces the pollutions again. Renewable diesels, HVO, hydrotreated vegetable oils, a distinct paraffin fuel chemically similar to petroleum diesel, not FAME, that is biodiesel, often called green diesel. So here is the molecule structure for petroleum diesel and biodiesel. So where biodiesel contain oxygen, this extra oxygen will help to reduce the pollution. Here we can see that biodiesel has many significance as compared to it has viscosity. Diesel has 2.0 to 4.5 and biodiesel has 3.5 to 6. That is higher than diesel, right? If we talk about cetane number, greater the stain number, it is easy for combustion or ignition point is high. So we can say it has better stain number also. Like the diesel has 40 to 55, but biodiesel has 47 to 65, which is quite better. It also improves ignition quality. So these are some properties that we can compare. And most important thing we can discuss here, that oxygen content, which is zero in diesel, and it is here near about 11%, which make it more cleaner. Biodiesel has 11% oxygen, which makes more cleaner fuel. Also helps to complete combustion so that the residues parts converts into carbon dioxide rather than carbon monoxides. Also, the biodiesel don't have any sulfur, so we can say it is sulfur free. And yes, we can say it will help to negligify the SOx emission, sulfur oxides emission. So that will be better for option for a fuel. So here we are going to discuss feedstocks and production. The production will explain also the process of transesterification that I was discussed earlier also. So yes, we have few options which will helps to which can use as the raw material for biodiesel. Let us discuss one by one. So first of all, we have first generation, that is edible. Edible oils are available, like we can get oil from soybean oil, dominant in America's reliable supply chain, but food versus fuel concerns. Next is we have one more edible option, that is palm oil. Southeast Asia is the region where we can get from. High yield but significant deforestation concerns is mentioned here. Now, second generation that we can say non-edible oils. Jatropha and camellia or castor oil, these are the other examples. Yes, castor oil has high viscosity, often requires for blending. And Jatropha, drought-resistant shrub, grows on marginal lands, but these oils are not edibles. Next, we have waste or residue, that used cooking oil, we will call it UCO, lowest carbon intensity Pre-treatment also required here. Animal fats, that will also helps to produce biodiesel. Next is yellow brown grease, that is high free fatty acid, that is FFA, contain needs acid esterification. Last we have third generation, that is advanced microalgae, extremely high yield per acre, R&D stage due to harvesting, and we have to consider this option also. So here trans-esterification can be easily understood with this slide, as the oil and fat will react with alcohol. Catalyst is also required, where the catalysts are potassium hydroxides or sodium hydroxide, but the temperature conditions are 60 degrees Celsius, and we get biodiesels. Also, we get byproduct like glycerol. So here we can easily understand the process transifigation, which is used for produce biodiesels. Catalyst we require for the process. Base catalysts are sodium hydroxide or potassium hydroxides, are standard for fast reaction but required low FFA. Acid catalyst handle high FFA feedstock but react much slower. Molar ratio, impact, temperature and mixing. Temperature required 60 degrees Celsius for this reaction. Byproducts we get, but still we have to manage all these products and quality control. So byproduct management consists glycerol separation, which is must from the biodiesels we get from the trans-esterification. It should be removed as it is less, which is greater than 98% pure required. Crude glycerol often contained methanol and soaps. Soap formation caused by free fatty acids reacting with base catalyst must be spilled or washed out. So this is the basic process we required. Methanol recovery also required here. Excess methanol distilled and recycled to improve the economics. Next we have purification process. Wet washing is there for purification process. Uses water to remove soap, catalyst and glycerol, generates wastewater. Dry washing, which is used ion exchange, resin or absorbent, reduced water uses. Polishing, final filtration to remove the micron scale, particulates and moisture. Quality assurance, ASTM D6751 or EN 14214, which is the standards for biodiesel, strict specifications, final fuel must meet before blending. Reaction completion measured by total glycerin, mono-DI, triglycerides remaining, and flashpoint check ensure methanol has been adequately removed. So we have some issues also. High water content promotes the microbial growth and hydrolysis, acid formation, and metal like sodium, potassium, calcium plus magnesium catalyst residue that causes injector fouling, and DPF ashes accumulates. Pre-glycerin separates at bottom of the tanks which closing the fuel filters. So it is also a big issue which we have to improve. Here next we are going to discuss about fuel properties and standards also, which are standardized by the governments. Critical properties and how they are specified, we all are going to discuss here. Few properties are important to discuss here, which is clearly explained in graph that a biodiesel has high viscosity. Cetane number is also higher than the diesel. Here we can get the information about the oxygen content. Yes, we already have discussed that biodiesels have oxygen, but the diesel, we don't have any kind of oxygen component or molecules. So first of all, let's discuss step by step viscosity and density. So we can get the information from the graph also that higher viscosity, that is 1.9 to 6, impacts the automation and pump efficiency. Density increased by 4 to 5%, affecting the injected fuel mass. So next is ignition quality. Higher cetane number also improved here in biodiesel. Like it is from 47 to 65 that we have discussed in properties also. Compared to diesel, ensure to shorter ignition delay, as diesel has a greater diesel ignition delay, but biodiesel has shorter ignition delay. Smoother combustion and also reduce the noise. As faster as combustion happens, it will definitely reduce the smoother combustion and reduce the noise also. Next, we are going to discuss the energy content, that LHV. So 12% lower energy density by weight, that is 37 versus 42 mg per kg, leads to increase the volumetric consumption for equivalent power. If we want to get the same power, it is also increase the volumetric consumption. So oxygen content is most important point we are already discussing. Again, contain 10 to 12% oxygen by weight, promoting the complete combustion, which is very important part of this biodiesel, and significantly reducing PM and soot emissions. We have few important parameters includes like free glycerin, water content, acidic number, metal like sodium, potassium, calcium, oxidation stability. It Poor quality biodiesel can causes injector deposition, filter clogging, DPF ash accumulation, or warranty voids also. Biodiesels and handlings we are going to discuss. So here in this slide we can see cold flow properties, that is cloud point CP, and cold filters plugging point, that is CFPP, determines winter operability. Biodiesels get higher temperatures than diesels. Saturation influence, saturated esters have better stability but poor cold flow. Unsaturated esters like soya or canola flow better but oxidized faster, which is again an issue to discuss. Oxidation stability measured by refinement method, that is critical for storage life. Oxidation leads to gums and deposits. Antioxidants are essentials. So we have few standards. So let us discuss first pure biodiesel, that is B100. That standard is ASTM D6751 USA or Canada. Applies pure B100 prior to blending and focuses on the physical properties and containment limits. Second is EN 14214, that is Europe is using the FAME standards, stricter on oxidation stability and iodine value that limits some feedstocks. Here in India, IS 15607, national standards adapted for local feedstock like Jetorfa and Karanja. So we have critical differences, that is iodine value EN 14214 caps at 120, ASTM has no limit, and cetane number EN requires minimum 51 and ASTM requires minimum 47. Blend specifications also discussing here. ASTM D975 standard diesels allow up to B5 5% biodiesel as a generic components like ASTM D746M covers blend from B6 to B20, crucial for fleets using higher blends. EN 590, the EU automotive diesel standards caps FAM, that is contained strictly at 7%, that is B7. Identity and quality assurance, pump labeling US FTC requires distinct labels for B6, B20 and B20 plus, B5 often unlabeled, BQ 9000, voluntary quality accelerations for producers and marketers to ensure this fuel warranty. Most OEMs sports B20 if it meets D7467 uses of no fuel voids warranty. Many test methods are there. So next we are going to discuss blends and handling. Biodiesel is commonly used in blends. B5 up to 5% of biodiesel, that is considered a standard fuel specification, a drop-in replacement requiring no engine modification, widely warranty friendly. Next, we are going to use B20, which is most common fleet blend, and B100 pure biodiesel, which needs care to handle. Here we have some properties: viscosity trends, energy density, and stain benefits. Storage and handlings. Also, we have to consider the points that biodiesel absorbs moisture easily. It has limited storage life, that is, we can use it for 6 months only, and clean old diesel deposits from tanks. So it is a major issues that we have to consider. Proper storage practice includes keeping the fuel dry, avoiding copper and brass, using antioxidants, regular filter check, which is very important to keep in mind using the biodiesel carefully. So now we are going to discuss the engine performance. This is graph which is completely describe all the properties and also compare the trends. So BSFE, that is brake specific fuel consumption. BSFC increases with biodiesels because of lower heating value. For B100, BSFC may increased by 10 to 12%. BTE, that is brake thermal efficiency, BTE remains nearly the same for slightly improves due to better combustion. Next, we are going to discuss power and torque. B20 negligible power loss and B100 is showing 5 to 8% reduction without recalibration. Higher the viscosity affect the automation, so higher injection pressure is required. Cold starting is more difficult at low temperature, especially for high blends. So here we are discussing power and torque outputs. Energy content drops. Biodiesel has 10 to 12% lower heating value LHV than diesel. That theoretically reduces the peak power if fuel volume is constant and density compensation. Higher density results in greater injected mass per stroke and net performance impact. B20 typically shows negligible loss, that is less than 2%. B100 may show 5 to 8% reduction in max torque power or without any recalibration. So next, we are going to discuss about combustion characteristics. Here we have graph which is showing few properties comparison between diesel and biodiesel. As biodiesel is high stain number, causes earlier auto ignition, reduces the premix spike magnitudes. Biodiesel has higher stain number, that means shorter ignition delay, earlier combustion, lower combustion noise. Heat releases rate shows that lower premix combustion peak, smoother the pressure raise. Biodiesel allows better control of the soot NOx trade-off, especially when combined with EGR and optimized injection timing. So next we are going to discuss emission environment. Here we can see that particular matter. There is a general trends about B20 and B100, and next primary mechanism is also there. So yes, we can see that PM is decreasing with the value 40 to 50%. Hydrocarbon is also decreasing with 60 to 70%. Carbon monoxide is decreasing with the value 40 to 50%. Sodium oxides, sulfur oxides completely 100% negligible because it do not contain any kind of sulfur. And nitrogen oxides is also slightly higher, engine dependent. That is which kind of engine we are using here. So modern alternate after treatment systems, we get DOC works efficiency, DPF regenerates faster, SCR effectively removes NOx. That is, thus with modern engine, biodiesel gives overall emission benefits. Here we can see that is oxygen content. Biodiesel contain 10 to 12% of oxygen by weight within the ester molecules. Now this oxygen will help for the combustion. Zero aromatics. Unlike diesel, biodiesel lack benzene, rings, and polycyclic aromatics. High stain numbers that we have already discussed, that it is from 50 to 65 compared to ULSD, that is 40 to 50. Enhanced oxidation. Internal oxygen adds combustion, fuel rich zone, reduced precursors, few available for shoot for mating growths, shorter the ignition delay, which helps to short the ignition delay, advances combustion phasing, reduces premixed burner spikes. So, minimum of premix carbon monoxides and hydrocarbons, which is helpful for the future fuel requirement. So here we are going to discuss the after treatment. So engine outs, we get NOx or PM, SC, CO, that is hydrocarbons and carbon monoxides. Diesel oxidation catalyst, which is used for the process, that is which oxides the hydrocarbons and carbon monoxides. Biodiesel is completely okay. And DPF, diesel particulate filter, which is most important to filter these traps or shoots. Still, we have ash risk, which we have to clear time to time. So how we can control these problems? High conversion efficiency, selective catalyst like reduction SCR, system remains highly effective, more than 95% with B20, blends with requiring no major hardware modification. Exhaust composition changes, that slightly higher engine out and NOx and different hydrocarbons profiles can alter then NO or NO2 ratio, sometimes adding low temperature activity. Urea dosing strategy is also useful. So here we have life cycle assessments, feedstock that we can get from farming, fertilizers, water or waste collection, and production like the process, transesterification, energy methanol catalyst. Then we have to discuss distribution, transport to terminals, shortage and blending, and definitely use phase internal combustion. Just give me 2 minutes, then we will continue the seminar. Okay, let's continue the session. Before going further, let me summarize the last topic we are discussing here. Combustion characteristics. Biodiesel has higher strain number as we have already discussed. So definitely it will give shorter ignition delay, earlier combustion, lower combustion noise, right? So we can also get the benefits that heat releases rate shows lower premix combustion peak or smoother pressure rise. Biodiesel allows better control of soot, especially when combined with EGR or optimized injections. So then we are discussing emission and environments. So these are the emissions that we get in biodiesels. Particulate matters, hydrocarbons, carbon monoxides, nitrogen oxides, sulfur oxides. So if we are talking about particulate matters, which is definitely decreases in biodiesel if we compare with diesel. Oxygen contents promotes the complete oxidation, lower aromatic contents, reduces soot precursors, hydrocarbon decreases as compared to diesel, like high stain number leads to shorter ignition delay and better combustion efficiency. Next parameter, which is another pollutant that we get in diesel combustion, that is carbon monoxide, which is decreases in biodiesel combustions. As we have discussed, extra oxygen is there to convert carbon monoxide into carbon dioxides. So oxygenated fuel structures ensure more carbon is fully oxygenated to carbon dioxides. Nitrogen oxides, which is slightly increases in this procedure or this diesel, uh, advanced injections timing due to bulk modules, and higher flame temperatures. Sulfur oxides are completely eliminated because biodiesel is naturally sulfur free and as compared to fossil fuel diesel limits. So here we are discussing mechanisms, fuel properties, combustion mechanism, and emissions outcomes. So first of all, oxygen content. Biodiesel contains 10 to 12% of oxygen by weight within the ester molecule. Enhanced oxidation. Oxygen contents helps to enhance oxidation. Internal oxygen aids combustion in fuel-rich zone. And emission outcomes will definitely improve, like it will decrease PM, carbon monoxides, and hydrocarbons. Significant reduction in particular matters, that is soot, residues of carbon like material, carbon monoxide, and hydrocarbons due to complete oxidation. Zero aromatic. Unlike diesel, biodiesel lacks benzene rings and polycyclic aromatics. So which will help to make it zero aromatic. So it will definitely reduce precursors, fewer nuclei available for soot formation or growth. Nitrogen oxides variability, slight increase often observed like 1 to 4% higher local temperatures or advanced timing promotes thermal nitroxides formations. Next, we are going to discuss high stain number. Seti number is quite important parameter that we are going to discuss here, which is from 50 to 65 as compared to ULSD, that is 40 to 50. So it will causing shorter ignition delay, advances combustion phasing, reduces premixed burn spike. So here we have some after treatments. Engine out, that is nitrogen oxides, aromatic materials, hydrocarbons, carbon monoxides, that is diesel oxidation catalyst, oxidized hydrocarbons and carbon monoxides, and then diesel particulate filter, which is most important here to filter the residues that will traps the soot and also have ash risks. Dock reaction is interactions. Biodiesel oxygen content leads to lower engine out HC or CO, that is hydrocarbons or carbon monoxides, reducing DOC load. Lower sulfur content prevents the catalyst poisoning and sulfur formation. Exhaust temperature and may be slightly lower, potentially affecting height of time. Yes, DPF regeneration or risks. Faster regeneration, oxygen within biodiesel suits structure lower the oxidation temperature, which is the balance point. Ash accumulation, trace metals, sodium, potassium, calcium, magnesium in biodiesel in form of incombustible ash, potentially plugging DPFs over time. So here we can discuss engine performance and combustions. Nature engines B5 and B20 works smoothly. B20 gives best balance and B100 needs heating and material changes. Combustion is smoother, noise is lower and smoke is less. It also have emission and health benefits. As we have discussed that it reduce many of pollutants. So definitely it will help to reduce the risk to health. Like health impact is huge. Diesel smoke causes asthma, lungs diseases, heart problems. Biodiesel reduce PM up to 50% that we have discussed here. Also reduces carbon monoxides, hydrocarbon, sulfur oxides, that is almost zero. So for plant operators, this is direct health benefits. So here we are going to discuss about the SCR, nitrogen oxides control. So we have high conversion efficiency, selective catalyst reduction, that is SCR system remains highly effective with B20 blends requiring no major hardware modification. Exhaust composition changes, slightly higher engine out nitrogen oxides and different hydrocarbons profiles can alter the nitrogen monoxide and nitrogen dioxide ratio, sometimes adding low temperature activity. Urea dosing strategy. calculately maps for AdBlue DEF injection may need re-environment to match the nitrogen oxides flux and prevents the ammonia slip. So here we have a life cycle assessment. First of all, the raw materials, feedstocks, farming, fertilizer, water, or waste collection. Next, we have production, which is definitely use the process of transesterification, where energy, methanol, catalyst are required. Then we have we have next step, that is distribution, which includes the transport to terminals, storage, and blending. And definitely we have use phases, internal combustion. Here we are going to discuss LCA results by feedstocks. Waste feedstocks used cooking oils, that is UCO and tallow, offer the highest reduction, that is greater than 85%, as they carry zero upstream production burden in most LCA models. Next, we have crop variability. First generation crops like soya typically yields 40 to 60% saving. Values are highly sensitive to fertilizers and used as farming efficiency. ILUC risks are also there, that is indirect land use changes, for example, biodeforestation for palm and negates benefits, potentially exceeds fossil diesel's emissions. Now we are going to discuss the practical consideration like materials, cold flow storage, or calibration and durability. So here we can discuss about the components, their properties, diesel and biodiesel comparison, and also the recommendations. So life cycle assessment shows that waste based on biodiesels like 80 to 90% GHG reduction, crop-based biodiesels 40 to 60% reduction. Economic factors are there. Feedstock price dominates the cost. Waste oils are cheapest. Government policies encourages low carbon fuels. Future policies focus on carbon intensity, not just the fuel volume. So which is very important to discuss. So here we are going to discuss the properties of components like NBR, that is nitrile rubber, compatible with diesel, swells or degrades risk in biodiesels. Also recommendations, replace with Vaction for blends B20, prevents the seal industry. Fluorocarbon Viton, that is compatible with diesel, compatible safe with biodiesels. industry standards material for all the biodiesel blends level. Materials like copper, brass, bronze, these metals are compatible with diesels. Oxidized with biodiesels or corroded avoid also happens. Causes fuel oxidation and sediments. Uses stainless steel or aluminium. Next material is zinc, lead, tin, which is again compatible with diesel but incompatible avoid with biodiesel. Forms deposits, that is sops. Avoid galvanized tanks or soldered filtering. Soldered fitting. Next is lubricity, HFRR, which is near about 400 to 600 and less than 300, in which is excellent for case of biodiesels, and significant wear reductions for fuel pumps and injectors. Here we are going to discuss cold flow, blend strategies. Seasonal adjustment reduces biodiesel ratios like, for example, B20 to B5 during extreme cold periods. Kerosene blendings, mixing with first diesel, that is kerosene, significantly lowers cloud point, which is CP. Feedstock selections also very important to consider according to the strategies, that is preferred repaste canola, esters over palm, tallow for winter uses, chemical additives, CFI, cold flow improvers, polymers that inhibits crystals growth and agglomerations. PPD, lower the temperature at which fuel ceases to flow. Anti-gelling agents, that is specially designed to prevent the filter plug-in in fuel lines. So next we are going to discuss vehicle hardwares, heated filters, electric heating elements integrated into the fuel filters housing, line heaters warming the fuel lines to prevent crystallization during transits, fuel returns recirculation, that is directing warm return fuel back to the filter or tank. So next we are going to discuss storage and handling. Indoor parking, keeping the vehicles in heated garages, prevents cold soak overnights. Tank insulations, insulating the bulk storage tanks to maintain the stable temperature, which is very important to consider. Temperature monitoring, which is again important for handling the biodiesels. Daily checks of bulk tank or temperature during cold snaps. Storage stability management, environment and antioxidants, which are required for storage. Oxidation rates accelerates with heat and lights. Uses antioxidants like TBHQ and BHT immediately post production of minimize the headspace air exposure. Contamination control is also required there. Avoid copper bronze fittings with catalyzed oxidation. Metal deactivators can be help. Keep tank clean to prevent the microbial sludge or water. This sludge will make a big problem with the diesel engines, biodiesel engines also. As we are not going to change the technology, just we are cleaning the fuels. So we have to keep this mind that the technology requires the clean fuel. If we have these kind of sludge or water, that will affect the engines also. Periodic monitoring is also important here. Test acid number, that is AN, or oxidation stability monthly. AN increases greater than 0.50 mg, that is potassium hydroxide per gram, and indicates the significant degradations of the material, that is biodiesels. Engine calibration we are going to discuss with this slide. We have some parameters that we are going to discuss. In case of diesel, calibration strategy, technical rationals. So first parameter we have injection timing. Next we are going to discuss fueling quality, quantity, rail pressure, EGR rate, material upgrades, service intervals. Injection timing for diesel baseline standard maps, that is calibration strategy retarded with 1 to 2 degrees CA delay. Technical rationals, that is biodiesel has shorter ignition delay, retarding timing, prevents excessive peak pressure, and reduces sodium oxides. Fueling quantity. So for diesel, energy demand, calibration strategy increases by 5 to 9% of volume, compensates for lower heating value, that is LHV, to maintain the power and torque output parities. Next is rail pressure, which depends completely on speed and load, which increases 5 to 10% pressure, improves the automation of higher viscosity fuel, prevents the droplets, agglomeration, and incomplete combustion. As incomplete combustion creates sludge, which is harmful for the engine. So next we are going to discuss EGR rate. As sodium oxides targets in diesels increase, fluoricides use higher exhaust gas recirculation to lower the combustion temperatures and contract the sodium oxides. Material upgrades, that is nitrile, Viton, FKM Vital, prevents seal swelling and degradation, critical for fleet running high blends, that B20 plus for long terms. Service intervals, that is standard, shorten initial monitor, early filter changes required due to cleaning effect, dislodging tank, sludge, verify oil dilutions. Here, few points we have already discussed. Let me recall all the points here. Like life cycle assessment, which is shows waste-based biodiesel is up to 80 to 90% GHG reduction. Crop-based biodiesel, that is 40 to 60% reduction. And economic factors, we already have discussed that feedstock price dominate cost, waste oils are cheapest, government policies increases low carbon fuels, and future policies focus on carbon intensity, not just the fuel volume. So here we are discussing durability and deposits. So first of all, we have injector fouling. Internal diesel injector deposits form from metal salts like sodium and potassium, and oxidation products causing needle striking and power loss. Piston and ring deposits. Unburned high boiling esters can cause piston crown lacquer and ring striking, leading to increased blow by oil and dilution. Filter plugging. Participation of strol, glucosides, monoglycerides, and soaps can rapidly clog fuel filters, especially in the colder operations. So definitely during colder operation, we have to consider all these points. So next we are going to discuss economics, policy, and supply chain like costs, logistics, regulation, and incentives. So this graph is showing the economics and its supply chain. So first of all, we are going to discuss the major cost drivers. Feedstock price dominates 60 to 80% of the total cost. So raw material is the major part for the cost, like methanol, catalyst, and energy inputs also contributes significantly to OPEX. Next, we have production economics. Economies for scales reduce processing costs, revenue for byproducts like glycerol or seed meals is critical for competitiveness. Now, logistics and supply chain. Challenges includes UCO, used cooking oil collection network, which is again a major point that we have to consider. Heated transport for high melt point fats and separate storage terminals. Policies. So we are going to discuss United States, which is RFS and LCFS, renewable fuel standards, that is RFS2, mandates volume obligations, utilizes RINs, that is renewable identification number, for compliance trading. Then we have LCFS, that is low carbon fuel standards. California, Oregon policies focus on the carbon intensity, that is CI reduction scores. Standards we have for United States, that is ASTM D6751 is the critical spec for V100 blending stock. For European Union, the Renewable Energy Directive sets the ambitious targets for renewable energy in transports, that is 14% by 2030. Sustainability criteria, strict limits with the indirect land uses change that ILUC risk, for example, phasing out high risk palm oil. Standards here are using EN 14214 defines flame requirements. High blend mandates. Indonesia B35 highest mandatory blend globally to support the local palm industry and reduces imports. Next, we have Brazil, that is Renova Bio, targets B15, decarbonization credits CBIOS, that is incentivize efficiency. And for India, national policy on biofuels targeting 5% biodiesels blending by 2030 using UCO non-edible oils. Next, we have global certification, ISCC, traceability, that is ISCC, International Sustainability and Carbon Certification, track feedstock from farm to fuel. Next, we have verification, essential for exporting to EU markets to improve GHG saving and zero deforestation. So here we are going to discuss risk and limitations. Cold flow and stability. Cold flow stability shows poor low temperature fluidity, that is gelation, and oxidation degradation during long-term storage remain primary operational hurdles. Then we have quality variations. Feedstock diversity leads to variable fuel properties, that is viscosity and cetane number, and affecting the consistent engine performance. As engine performance is completely dependent on the quality, which is variable, so performance will also show the variations. Material issues, incompatibility with certain elastomers and potential for injectors deposits, IDID, in high pressure modern system, and sustainability, ILUC, which will concern over indirect land use changes and food versus fuel debates derive policy towards waste or advantaged feedstock. So here we have a roadmap. So let's summarize and discuss some case studies. So first of all, we have emission benefits, significantly reduction of PM, carbon monoxides, hydrocarbons, and carbon dioxide neutral in life cycle, feedstock dependent. Operational changes requires management of cold flow, property storage, stability and water content, engine compatibility, B5, B20, and widely accepted drop in solutions like B100 requires material upgrades. So yes, we can conclude our discussions like biodiesels are renewable, cleaner, compatible with diesel engines, ideal for heavy duty applications. Challenges like cold flow storage stability and sodium nitrogen oxides can be managed with the proper fuel quality, blending, and engine calibration. So also we have discussed B5 and B20 blends are particle safe and widely accepted today. So let's conclude all the things. Biodiesels allows us to act today, not tomorrow. So we are not dependent for the future to improve the quality of fuel. We can improve the quality of fuel. Also, we can diminish or decrease the disadvantages of diesel that we are already using in the present days. So yes, here I am concluding my things that we have discussed in this seminar. And thank you so much. I hope it will be beneficial for all of us.
Thank you so much, ma'am, for sharing your valuable insight through such an effective session.
Thank you so much, ma'am.
Now we will proceed to the next session. The session link will be shared in WhatsApp group. Thank you all for joining us.
Thank you, ma'am. Thank you once again.